Action means organizing the objects together. You used array, you used set, you used list, you used queue, you used map. Yesterday, enum. Enum also collecting objects. That's the point. So finally, what is today's class means? The list of objects generated from core Java. Make a siding here. Today's class is list of objects generated from core Java. List of objects generated from core Java. So majorly 7 objects. These 7 objects are core Java objects. Core Java objects. Write that list once again. This is map. This is here we write complete list of objects. Complete list of objects. Complete list of objects means user defined class object will be only one anyway. String objects will be 3. String class objects. What is the second one now? String buffer class objects. String builder objects. String builder class objects. These 3 are from string. Under wrapper classes, 8 will be there. Under wrapper classes, 8 will be there. One is integer, not integer. One is byte objects, short objects, integer objects, long objects, float objects, double objects, character objects, Boolean objects. There are 8 types available. 1, 2, 3, 4, 5, 6, 7, 8. array objects. Array holding user defined class objects. Array holding string objects. Array holding wrapper class objects. Array holding array objects. Array objects. Array holding array objects, you can call it as jagged arrays, you can say. Array holding dissimilar objects. You can say object array, you can say. Under collection, we had set, we had list, we had queue, we had DQ, we had it. DQ. We had a DQ. Now, under set we had it. I forget write it. Hash set objects linked hash set objects tree set objects. Linked list, array list objects, linked list objects, vector objects. Here, stack objects. Under queue, we had priority queue objects. Priority queue objects. Under DQ, I had array DQ. Objects. Linked list objects. Hash map objects. Linked hash map objects. Frame map objects. Hash table objects. So these are the complete list of objects. Complete list of objects. Right. So this is the total list. User-defined class objects, string objects, wrapper class objects, array objects, set objects, list objects, queue objects, DQ objects, map objects, and enum. So our journey will be ended with enum. Actually, the knowledge purpose comes and starts by enum. If anybody asked how many objects means, you must say 7. So you personally know what it contains. There's a list actually. So there one FAQ question will come. What is the difference between container objects, utility objects, container objects, utility objects, and cursor objects? One question is there. What are container? What are utility? What are cursor? One question is there. Container means they hold data. Container means they hold data. So objects which hold data are known as container objects. The objects which hold data are known as container objects. The objects which hold data are known as container objects. Above all objects are container objects only, because they are holding data. You can say container. Utility objects. the objects which perform operations on other objects. The objects which perform operations on other objects are known as utility objects. The objects which perform operations on other objects are known as utility objects. The first utility object is scanner. Do you remember scanner class now? Right. Scanner class will perform operations to load the data to another actually. It will not hold data, it transfers the data. It will not hold, it transfers the data, act as an intermediate transfer. So you can say scanner is utility. And second one is under string chapter, we had a string tokenizer. Do you remember? String tokenizer. One class is there. In the same class, I introduced a string joiner. String joiner. These three I introduced. Two more I not introduced. One is arrays. One is collections. One class is there I not introduced. Collections, plural form. Now, cursor objects. The previous program is cursors only. The objects which are used to retrieve data from collection objects are known as cursor statements. Cursor objects, you can say. The objects which are used to retrieve data from collection objects. That's cursor objects. Example, you had notes on them already. Iterator, you know, but I'm repeating the names. List iterator. List iterator. Enumeration and special iterator. Iterator, list iterator, special. So these are all comes under cursor objects, you know already. Now, we had one question. FAQ. What is the difference between collection? What is the difference between collection and collections? Don't say singular and plural. I said to you one answer, one student answer that only. Singular, plural. Throws. Singular, plural. Collection, singular, plural. So collection means interface, collections means class. I not introduced any, still arrays class because I not done sorting on array. I not done sorting on list. The two methods are waiting. The two methods are available from these two classes only. I'll use it. So you write one statement like this. Collection is an interface from java.util package and which is root of Java collection framework. Collection is an interface from java.util package and which is root of Java collection. You know this already, collection. So collections is a class. Collections, you write in double quotes like this. Collections is a utility class from java.util package and which provide the following methods to perform operations on collection objects. Sir, what methods it provide? It provide a method known as sort. S-O-R-T, sort method. It provides binary search. Two methods available from here. Sort method and binary search method. There's two methods available. So collection I still not used. Frankly speaking, I not used collection till now. Now, where I'm going to use collection means, now there are some methods left here. Actually. If we take set, the first one is set only. Set, contain all, add all, retain all, remove all. This one used, this one used, this is not used. Like this, 4 or 5 methods available. Sort already you are doing with tree set already. So when you come to list contains all, add all, remove all, retain all, replace. Can I see sort? So one sort method I not used still. This I am going to use it. Down. Iterator, list iterator, sublist I not used. So this one I not used. Means here also 4 or 5 methods pending. When you come to queue, I used all. Queue, nothing is there. It is easy. So totally their sort method available in the list and remaining 1 or 2 mixing methods are available. Okay, right. There I'm going to use that collection and arrays. I'm going to use it as a plan. Okay. Meanwhile, here under programming concepts, object oriented almost nearer because object collection we done. So next level is object lock, object clone, then object sort. Last one is sorting. Then sort method will come. Last part. So here already Java collection framework here. Collection means grouping anyway. Under Java collection framework anyway, data structure. I said one statement, no? the process of organizing data in a proper format. We call it as data structure. In other languages, means C language especially, you must compare with C language. In C language, data structure is popular. Why popular? Manual code is there. Everything you must write manual. API is not available there. Java data structure is not popular. Why? Means predefined. Stack available, queue available, list available, set available. So they are all predefined, constructed and available to you. So if you want write, you can write manual. For loop support is there. Understood the statement? So here the components available to you. The components available to you. How the components are available? Sir, I can use arrays. I can use arrays. Sir, I can use set. I can use list. I can use list. I can use queue. I can use queue. I can use map. I can use map to organize the data. I can use enum. Enum also grouping only. I can use enum. So these are the components available with us to order the data. So the statement to you, data structure is nothing but organizing the data in one proper form. In Java, how you can organize them means by using set or list or queue or map or enum or array. Enum array not needed, remaining are popular. Set, list, queue. That's only concept we highlighted. So here one awareness is available. Here 150% awareness is there. Here some awareness is there. Here some awareness is there. So here object collection means grouping. Here I must do object locking. I must do. Then I must do object cloning. I must do. Then I must do object sorting. This is the order. Because the last one is sort. So before doing all these sort methods, let us do object lock. Whenever you want to do object lock, we enter into this part. What is this part now? Multi-thread. We complete that object locking. There also interface will be there. Object locking, we come out. Then we write your object clone. We do it. Then we do object sort. And there the levels will be ended. Then we conclude. So now make a sliding multi-threading process in Java. We are entering to lock the objects. Object locking. Star mark IMP. Multi-threading process in Java. Multi-threading process in Java. Define application. Define application. Now, set of programs collected together to perform defined action. Set of programs collected together to perform defined action is known as application. Set of programs collected together to perform defined action is known as application. Suppose to discuss this part, we must imagine one application. You have to imagine it. See there, I'm imagining one application here. General applications, always we imagine it. Any application, same format will be there in the real time. That applications will be same format, no other choice. If you take any bookstore application, if you take it, so one user should register. This is common to all the applications. One user must log in. The users can see the books, view books. If he want, he can buy book. If you want, he can add that book to cart, add to cart. Later on, he can buy. So if we don't want, he can log out. This is general applications. So any application registration common, generally user registrations. So set of programs collected together to perform defined action. We call it as application. It's a theory. Now this application should be used by some users. This is application. Must be used by somebody. Okay, right. Now, whenever I want to use this application, your users, some users will come from web browsers. Our applications are web application only. Web browser. www.bookstoreapp.com. Through web browser, we are executing the application. What I'm trying to say here is, now these are all the programs inside the application now. Now user is calling the program, calling the application. Calling the application, not the program. He never call add to cart, he never call logout. He calls application first. www.gmail.com application. www.facebook.com application. www.irctc.co.in application. www.bookstore anyway. So these are all applications. So we are calling application for execution. The statement is define process. Define process. Process English meaning is execute. Define process. So what you are executing? The application under execution is a process. The application under execution is a process. The statement is according to Java. The application under execution is a process. The statement is according to Java, it is a statement. Define task. Define task. The part of process is known as task. The part of process is known as task. If anybody asked, task means part of process. The part of process, we call it as a task. So according to our application here, according to our application, this is one part. 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 So each one is one task. This is one task. This is one task. This is one task. So each one is one task, because they are all parts of application, no? Right? Application has almost 6 parts. So according to Java application, each program in application is a task. So task means part of process. Process means application under execution is a process. Then what is task now here? According to Java application, each program in application is a task. Make it note. According to Java application, each program in a task. According to Java application, each program in a task. Each program in application is a task. According to Java application, each program in application is a task. Right. Now look here. Suppose one more user came here. Suppose one more user came. http://www.bookstoreapp.com, like this. Any number of users can call it. This is user 1. This is user 2. Any number of users can call it, no restriction. Now, user 1 is a new user. That new user has to do registration. New user has to do registration. And second user is old user. He has to do login process. Now, two users are interacting internally with two tasks. Yes or no? When both are interacting with two tasks, you must do simultaneously. Simultaneously means some part there, some part here. You must do. If you do some part there, some part here on, then only two will get the answer. If I do one after the other, second person has to wait it, no. So what is the statement is? Define multitasking. Define multitasking means executing multiple tasks simultaneously. Make a statement. Define multitasking. Define multitasking. Executing multiple tasks simultaneously. Executing multiple tasks simultaneously is known as multitasking. Executing multiple tasks simultaneously is known as multitasking. Simultaneously means at a time, but not parallel. Simultaneously means at a time, but not parallel. Simultaneously means at a time, but not parallel. At a time means execution time will be same, but internally they are not executed parallelly. That's the meaning. Suppose if you attend core Java in the morning, Oracle in the evening, within 3 months, both will come out. Suppose if I attend one after the other, sir, it takes 6 months, sir. So that is attending simultaneously, time will be same, 3 months. That's the concept. Simultaneously means not parallel. Parallel means what? Left hand writing notes of core Java, right hand writing notes of Oracle. This is called parallel, not possible. Parallel, not possible. You will say no parallel batch. We only will write parallel. Parallel batch not there. Parallel means you cannot do at a time. Sorry. This parallelly you cannot do. Time will be same. That's called simultaneous. Here also, your author said, execute these two tasks simultaneously. Simultaneously means what are here? Some part here, some part here. Some part you do here. Some part you do here. And some part you do here. Some part here, some part here. After that, you do some part here. Then you do some part here. Like this, you are doing part by part. Some part here and some part here. There some part, here some part, here some part, here some part. That's called simultaneously. So when you are executing simultaneously, only some part of program is executing. No, sir, here. Not part of. Only part of task is executing here. Only part. The part of task what is executed, you are calling it as thread. That only concept. The part of task what is executed, you are calling it as thread. That only thread introduction. To find that thread only, we started with application. The part of task is known as thread. Part of process, task. Part of task, thread. That only concept. Our chapter is multi-threading, not multitasking, not multi-processing. It is a multi-threading, organizing and controlling multiple parts of task. That is our chapter. So multi-threading, because friend will not understand what it is. Because if you want to understand it, you must have application. Application under execution process. Part of process, task. Task part is, you are calling it as thread. Make it. Note. In the process of executing, multiple tasks, only some part of task, is executed. In the process of executing multiple tasks, only some part of task is executed, known as thread. In the process of executing multiple tasks, only some part of task is executed, known as thread. Known as thread. Right. So finally, definition available here, part of task. Anyway, even then we repeat it. Define thread. The part of task is known as thread. The part of task is known as thread. Here continuation. Thread is a lightweight and background process. Lightweight and background process. Thread is a lightweight and background process. Lightweight and background process. Lightweight and background process. Sir, what is this lightweight and background process? Right. Lightweight means consumes less execution time. Lightweight process. Lightweight process means consumes less execution time. Instead of executing the total task, if you execute only part of task, less time it takes. That's the meaning of lightweight. Background process. Background process means there is no separate identification. 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 If we look into this diagram, You can understand. Here, name of the task is register. Task is having a name. Part of task will not have a name. That only background. That's a background process. So background means name not available to it. Separate identification not there. That is known as a thread. Not only your others will say lightweight and background process. They'll say. And moreover, you can say child process also. Process means execute. Parent execution, child execution. Process English meaning is execute. So you can say child process also. That's the point. Now our unit is define multi-threading. Multi-threading. Define multi-threading. Executing multiple threads simultaneously is known as executing multiple threads simultaneously is known as multi-threading. Executing multiple threads simultaneously is known as multi-threading. Simply you can say executing multiple parts of multiple tasks. Multiple parts, one part from one task, one part from one task, and that's called thread. So that we call it as multi-thread. So this is your definition. So diagram will be pasted there to create an imagination to you what is application generally. Right. Now look here. This is the imaginary diagram. Imaginating application is an imaginary. Now, practically we'll do star mark IMP, creating and executing threads. Creating and executing threads. Creating and executing threads. Step 1. The user-defined class. The user-defined class must be implemented from java.lang.runnable interface. The user-defined class must be implemented from java.lang.runnable interface. Runnable interface. The user-defined class must be implemented from java.lang.runnable interface. Structure of runnable. Structure of runnable interface. Structure of runnable interface. Java P, Java dot lang dot runnable. So this is one runnable from lang package. It is runnable. Right. So runnable is providing one run method. Runnable is providing one run method. Right. Now that user defined class is the implementation of runnable. Step 2. The user defined implementation class must construct body for run method. Body for run method. And which is holding program logic. The logic you're writing under run method. That's my intention. You know the rule already. If any class implemented from interface, it has to construct the body for abstract method. It is providing run method. We are writing the body for run method. Inside that body, we write some program logic. We write it. Some program logic. We write it. Right. So whenever you constructed the body for run, if you want to call run method, you have to create object for user defined class. Make it step 3. Create object for user defined. Create object for user defined implementation class. Create object for. Noise is coming means that people will be 100% placement people only. Generally, you people will be decent only. Yes or no? Na? Louder. Because I used to go there, no? They will not learn. It's like a degree college only again. I used to go to that campus. Again, same like degree college only will be there. Degree college means what? Group meetings, wasting time, outings, chartings. Again, time will be wasted, no? Same. That is also they are doing same thing again. In colleges, why you don't learn it means because of friends. You know, learn it. Right. Create object for user defined implementation class. We create object. Create object for user defined implementation. This is common process. One interface. For that interface, we write one implementation. That implementation has to take the abstract method, write the body. If you want to run that method, create object. These 3 steps are common. Okay. 4th step is create object for predefined thread class. Create object for predefined thread class. There is one class known as thread, java.lang.thread. For that, we create object. Create object for predefined thread class. And while object creation, we pass user defined implementation class. Object reference as parameter. Create object for predefined thread class, and while object creation, we pass user defined implementation class object reference as parameter. Implementation class object reference as parameter. Step 5. Now, execute run method using start method. The 5th step, execute run method using start method. Execute run method using start method. Execute run method using start method. I'll explain that to you. Right? Okay. These are the 5 steps. By using these 5 steps, I'll write the program. Okay, right. I'll construct one program. Okay, right. See there. Suppose for demo purpose only, I'm taking. Suppose here book store app is there, no? Roughly. Of course, multiple web browsers not there with me. I'll run from the console only, roughly. Okay, right. Imagine I am taking one application, roughly, for demo purpose. I am taking one application. Book store app, roughly, for demo purpose. Now, inside this, I'll take 2 programs. I'll take program means class. Here, program means task. Okay, right. Now, register one program. Another program, I'll take it. The program is login. Roughly, I'm taking. One program name is register. One program name is login. So, according to our analysis, each program is one task. Each program is one task. Sir, this is one task. So this is one task. Yes or no? Now, right? 2 tasks. Imagine like this. Right? Okay. Now, what is the rules of constructing now, sir? If these 2 are user-defined programs, the rules, sir, they should be implemented from runnable. There is one predefined interface, runnable. This runnable is holding one abstract method now. Void run with empty parameters. No parameters, no. Right. So that is one abstract method. That is one abstract. Sir, this class, this interface linked here. This interface linked here. It should be implemented. That is a rules. Sir, it is implements. This is also implements. Now, what are the rules of implementation, sir? We have to take that run method. Void some run method. And here, void run method. Got it, everyone? Right. Okay. Now, here some logic I must write. Okay, right. Here, logic. Roughly, I'm writing one logic. Running one loop. sorry, 1 to 5, one loop I'll run. Here also 1 to 5, I'll run one loop. Okay, roughly, because I don't have web browser concept now, right here, just console. Some logic I will write. Okay, right. Now, what is the next step now? Sir, they are implemented. Next step is, sir, they must get one object. No, sir. For them, some object should come out. For this one object should come. For this one object should come. See, I'm constructing. Right. I'll take some bookstore app. This is one thread application. Roughly, I'm writing some name. I'm writing for demo purpose. Here. Under this, I'll take the packages. Of course, under application classes, our rules are they should be under packages. Packages, you don't count it. You count only classes. Under package, under test, I will take it. Under test. Under test class, I am taking one class. That only. Register, I will take it. Register, I will take it. I'll take one more class. That class is login, roughly. There are two classes. What are the rules now, sir? Implements from runnable. Implements from runnable. Now, whenever it is implemented now, public void run. I must write. So this method is overriding method. It's a override method of runnable now. This time commenting as override. Now, this is implements from runnable. This also public void run. Override. Now I must write one logic here. Roughly, I want to keep one for loop for output purpose. Int I is equal to 1, I less than or equal to 5, I plus plus. Here, system dot out dot println thread dot current so I kept one message. Registration for us. Right. I kept one message, 5 times it run. Okay, right. Registration. Here. System dot out dot. The chairs will be very much weaker. Please change the chairs. Login for thread dot current thread dot. Yep. I'll explain them. Whatever I write, I'll explain them. Okay, right. So anyway, I kept one message. It has to run for 5 times. Okay, right. Now I want to see the output bit slowly. I want to see. So which thread is running? I want to see. For that, I'm using one method known as a sleep method. Thread dot sleep 2000 milliseconds. I'll explain that anyway. I am asking to sleep for 2000 milliseconds. Right. I took it. Now, some name I took it. Our target is now, sir, some part must be executed here. Some part must be executed here. Sir, some part must be executed here. And some part must be executed here. After that, some part must be executed here. After that, some part, that only is simultaneous. Yes or no? Na? At a time, answer must not come, sir. There's some part, here some part, it should come. That only multi-thread. If normal execution, why this whole story? We can take and run, no? Right? But to create a thread flavor, only the story is going on. They should run simultaneously. Register, login, register, login, register, login. 2 users are running. User 1, user 2, user 1, user 2, roughly. Now I am going for, see, up to now 2 steps. Implemented from runnable, constructed body for run. You return some logic. The logic I'll explain it. What a thread, dart, current, it's my duty to explain anyway. That exception also I'll explain it. Don't worry. For output purpose, I written. The logic I'll take care, you have to wait it. Right? Leave that logic. Sub program I written. Now you have to create objects for user defined classes. No, create object. Whenever you want to create object, we go for test class. Test class means main class to run the program. So create one more package. Always we go with maccess. Maccess. So right click class. So demo thread 1. Anyway, import. Import the 2 classes now. Import test dot star. Now create objects for the 2 classes. One is register OB1 is equal to new register, one class. Login OB2 is equal to new login. After creating user-defined class objects, next what? Create object for predefined classes. Predefined class what now? Thread. And pass this reference as parameter. So I had two threads because two tasks are running now. I'll take thread T1 is equal to new thread. And one more, thread T2 is equal to new thread. For thread 1, I'll give OB1. For thread 2, I'll give OB2. Create object for user-defined class thread. While object creation, pass user-defined class object reference as a parameter. Then you have to call that run method by using start method. Why start method means in start method algorithm is there. T2 dot start. Start method is a predefined method from the library, which is having a thread activation algorithm is available. Now, who is T1? Who is T2? Give the names. Sir, T1 dot set name. The name is user1. So T2 dot set name. His name is user2. User2 roughly. Because according to diagram here, is user1 no. User1, user2 are roughly. Okay, right. Now this is the program. Let me run it. Both should execute simultaneously. Both are running simultaneously. See there. One part from registration, one part from login, one part from registration, one part from login. So two are running now. Actually, JM matrix, one by one should come now, sir. How two are running? Understood this point now, right? So two are running now. Two programs are running simultaneously. See, registration for user one. Output is coming from registration. And login for user 2. Output is coming from login. So two programs are running. Two programs, two methods are running simultaneously. The process of running two programs simultaneously, two tasks simultaneously. We are executing part of task. We are executing only part now. That part we are calling it as thread, means we are executing threads. We call it as multi-thread. It's a concept. Now this is the output. Sir, how this output came, sir? What happened internally, sir? I want to know, sir. Register dot.java, login dot.java, demo thread 1.java. This is main class. And this is output, followed by one diagram. So this program I'll explain by tomorrow. Tomorrow class is normal time 6 o'clock. Same room. Same room only. Tomorrow time is normal time. 6 o'clock you come to same room. Tomorrow 15 minutes I'll draw the diagram. You'll get the clarity. What is thread? I'll convert this program into lambda immediately. After that, I'll apply the lock on the object. Tomorrow, multi-thread will come to almost 90% will be ended. Only concept only pending. So tomorrow, 2 hours class, come by 6 o'clock. The same room, 6 o'clock. Got it right? Take a break for today. Thank you very much for today. Yesterday notes not update. Today I'll update.